rise and not turning. Is kind of the example there. This middle one will say, if I'm faced between like 0 and 180, face to the right. If I'm faced over on this side, face to the left. Okay, so full rotation, only left or right, no rotation. That took me, I think it was like my second or third time teaching Scratch before I figured that out. Yes. Okay. So here's 2 blocks that are about changing the variable x. So the character has a variable x, and these pieces look just like the ones we had for changing the variable length. So I can change it by 10, which takes its current value and adds 10 to it, or I can set it to 10 or 0 or whatever. On these, I really like to build off of students' ideas of like, the words set and change, you use those in real life, and these like represent concepts you're familiar with. Here are 2 more cookies. That's like change. I'm changing the number of cookies you have by 2. It gets a little bit trickier when you say, well, what if I change x by a negative amount? Okay? But again, kind of powerful mathematical ideas are embedded there. Well, I want to change it by -2, so it's going to be 2 less. So what about set? So set, instead of just here are 2 cookies, I say, you have 0 cookies. Okay? It's not about giving 1 or more or taking 1 or more. This set one just flatline establishes it. Students have, I think it makes sense to have a dialogue about the difference between set and change, because it's really common to just use the wrong one. I think a professional programmer in Scratch might accidentally use the wrong one. And so having the difference between set and change, something that your students in Scratch are attuned to, can be helpful for later debugging dialogues and supporting them in that.
Colleen?
Yeah.
I think it really is helpful to think about the words to and by there also. Mm-hmm. Set to.
Set to.
Is the difference between to and by is a more salient difference to me than the
set and change.
And I think, so the fact that that's a good thing to point out.
Yeah, I like that. So I think really emphasizing the difference, and I think Brian's right that the more salient piece is the to and the by. Yeah, Glenn.
I've also had a number of people that were really confused between this distinction here, and so I had some success breaking the change down into get, modify, set, so that change is actually an encapsulation of a number of steps, not just that culminates in a set. So you get the variable's value, you change the variable's value, then you set the variable, and then you stomp over the old value with this new value. And that actually seemed to help people kind of understand what the difference between modifying a variable and then versus just stomping over the top of it.
And also I find that, so Glenn's saying basically that I could say, well, set x to be x plus 10. Okay, and so you can make that really explicit instead of using a change, explicitly using the set for all of them. I find that that's really intuitive for college students, but I find that 6th grade students have less trouble with this. Where for college students, I found the more intuitive way, not a large n here, but the more intuitive way for them is to say set x to x plus 10. I find 6th graders seem to have less trouble with the change. They still use the wrong one accidentally, but at a core level, they seem to have the right intuitions around these. So try and build upon their regular reasoning for the idea of accumulating things and setting things. A big one, what is position? And do you guys want me to end in 5 minutes? Is that the plan?
Not really, not necessarily. I mean,
Okay.
anybody want to take a break? Everybody's okay? I'm enjoying this.
Thanks, Eugene. Okay, so again, kind of a meaningful context for using the coordinate system. So the Scratch has both negative and positive values of x and y, so you get the whole grid there. So here I'm setting the position to x and then y, or to x equals 0 and y equals 0. And now I'm ready to draw something. Yeah, and so I'm going to draw it, and it's really complicated, and I end up over here. And now I want to draw it again. So I move my character back to x equals 0, y equals 0. And I draw it again, and it doesn't trace exactly the same thing. And that's because whenever I draw something, it doesn't just matter exactly where my feet are, it matters exactly which direction I'm facing. If I'm ever telling the character, like I did with the square, move 200 steps, that takes whichever direction it's facing. Maybe I'm facing this way, and I'll move 200 steps. If at the end of my diagram, or at the end of my drawing, I'm facing in this direction, when you move me back to x equals 0, I'm not facing in this direction like you want anymore. Okay? So thinking about what is position. Position, like the moves 10 steps, also uses the direction to determine which direction it goes, instead of change x and y by something, which are just in the grid. So position isn't just like an x and a y coordinate like we typically talk about it. Position is also which direction you're facing. Okay? And so here, I think it's important to think about what we want for students to be able to predict what individual commands do. But there's a lot that individual commands are acting on, right? There's a lot of kind of tacit, unmentioned state that the new command's going to act on, one of which is this direction. So focus on the implicit input. So there's an implicit input or an implicit state before each of these commands. So it's not just where is its x and y, it's which direction is it facing. And those are the variables that are shaping the eventual path and the eventual drawing or the eventual result. Does that make sense? So there are these kind of hidden things in there where we think about position as just being x and y, but really we need a broader picture for the Scratch context for that.
You know, it reminds me of teaching logo because I actually made a logo cake, you know, a green turtle cake, and then had kids practice giving directions. So just the physical role playing, I think, is really, I mean, we really work at middle school and be good to help kids visualize.
Yeah, so the role playing can be really helpful. In logo, they called it playing turtle, or Pepper called it playing turtle. Something I do before doing any of the motion stuff is I take sidewalk chalk and I draw shapes on the ground. And what students do is they need to write instructions to be able to describe to someone how to move around in this shape. So before they even know that Scratch can move characters around, they're outside and they're using this limited vocabulary to be able to describe to someone how to move around a shape. Yeah, Margaret.
So what I'm finding fascinating is that at least 2 times now in the past 10 minutes, we actually explained what's behind the blocks. And so it kind of goes back to what Barbara said, which is where do you, the lingo is kind of like, I have a friend she speaks French. So they took their daughter to France, and the daughter does not realize she speaks French, but she understood everything that people in France were saying. So that at some point, I'm hoping that it kicks in that, oh, like you said in your trajectory, that it was easy because you were accustomed to thinking like the computer. But I'm just finding it interesting that, you know, because if you were programming in C++ or Java, yeah, you wouldn't say set X, you would say take X, add whatever, and you know, like what?
X equals X plus 10.
Right. You would actually do these things that we're trying to abstract away for these younger kids.
Yeah, and so I think the really difficult part in either learning C or Java or in learning Scratch is having your kind of mental model about how these variables can change and do change match actually how they can and do change. So I think it's really all about, well, I have some variables, I have some state, maybe it's the X position, the Y position, the direction, my variable length. And then I have another command, I have a new block that runs. How does it change all of those? And I think I haven't found particularly problematic things about how students are reasoning about those variables being set. In older logo research, there was documentation of students thinking that variables could hold multiple values. So I set X